Hola folks! I wanted to make a video to further explain the importance of the unit circle. I had mentioned that you need to memorize at least the first quadrant of the unit circle, and how if you can memorize the first quadrant, then that's enough. It helps you with everything else. So I want to further explain what I mean by that. First of all, you need to have an idea, even though you only have to memorize the first quadrant, you do need to have an idea of where all of the other angles are. So start with your four corners. This is 0 degrees. Then we know up here we got 90, and we got 180, then we got 270, and then again we have 360 degrees. Okay, from there I like to do my 45-degree angles next. So that's going to be 45 degrees. Then do 90 plus 45, which is going to be 135. Then do 180 plus 45, which is going to be 225. And then do 270 plus 45, which is going to be 315. Then you could do your 30 degrees. So we know this one's 30. And then 90 plus 30 is 120. Then 180 plus 30 is 210. 270 plus 30 is 300. Then do your 60 degrees. So this is 60. 90 plus 60 is 150. 180 plus 60 is 240. 270 plus 60 is 330. So you have to at least know how to generate all of that as well. And remember guys, the whole reason that we made these was out of our special right triangles. So, you know, that's where if you drop these horizontal lines here, you would end up essentially making all of those bow ties. I don't want to mess up my circle doing that, but that's where this comes from. Okay, so now you need to know the coordinate points. So let's just do the coordinate points of our four corners again. Unit circle being a radius of 1. So there's a radius from here to here is 1 all the way around the circle. And this is our angle in standard position. So that's going to be 1, 0. Up at 90-degree angles, this coordinate is 0, 1. At 180 degrees, this is -1, 0, and at 270, this is 0, -1. So those are pretty easy. Then you just have to memorize the other ones, or you could use your special rights rules and use your trig SOHCAHTOA there to figure out these ratios, but memorizing them is also not bad at all. The 30-degree angle, well actually let's start 45s, I think those are easy. All of the 45-degree angles, so the ones that, even though they're not 45 degrees, I'm talking about 45, 135, 275, and 315. Those are all square root of 2 over 2, comma, square root of 2 over 2. Then the 30-degree angle, notice its x value. So the x value for 45 goes to about right here, and then it goes up. Well, the x value for the 30 degrees goes a little bit further than the square root of 2. It goes the square root of 3 over 2 to the right, and then 1/2 up. So this here is 1/2 up the way on the y-axis. So that's another way of thinking about it. And then the 60-degree angle, it kind of goes down. So like this one, the 30 degrees, the square root of 3 over 2. 45 degrees is the square root of 2 over 2. So 60 degrees is the square root of 1 over 2, which is just going to be 1 over 2. Oh, lost my pen. Which is 1 over 2. And then it flip-flops with the 30-degree angle, right? Because 30, 60, 90 triangles are opposite. So it's going to be 1/2, then the square root of 3 over 2. If you can generate that quadrant, you can generate everything else. Because everything else has these exact same coordinate points, except the signs are different. Okay, so let's start with the 45 degrees again, because I think that one's probably the easiest. So for all of the 45-degree angles, they're all going to have the square root of 2 over 2 So that means 135 has 45 degrees as its reference angle. It's also going to be the square root of 2 over 2 and the square root over 2, except since it's in the second quadrant, we know that everything in the second quadrant is going to have negative, positive coordinate points. Everything in the first quadrant has positive, positive. Everything in the third quadrant has negative, negative. And everything in the fourth quadrant has positive, negative. Ooh, not negative 4. Positive, negative. So if those still have the same coordinates, then I know it's negative square root of 2 over 2, comma, positive square root of 2 over 2. Okay, then the 45-degree angle, so to speak, in the third quadrant is this 225, except it's both going to be negative. So negative square root of 2 over 2, negative square root of 2 over 2. And then the same angle in the fourth quadrant is going to be positive, negative. So square root of 2 over 2, negative square root of 2 over 2. So again, the same 4 coordinates, except the signs are different. Okay, so that takes care of the 45-degree angles. Next, let's do the 30 degrees. So this 30 degrees is already done. The square root of 3 over 2, comma, 1/2. So that same 30-degree angle in all of the quadrants is going to be, and it's going to be reflected over each of the axes. So if I reflect that one over the y-axis, then that means over here, I'm going to have that same coordinate, but instead of positive square root of 3 over 2, I'm going to have negative square root of 3 over 2, positive 1/2. In the third quadrant, they're both negative. So if I reflect this point over the x-axis, I get here, and that's going to be negative square root of 3 over 2, negative square root of 3 over 2. And then if I reflect that over the y-axis, I get here, where it's positive, negative. So square root of 3 over 2, negative 1/2. Again, all the same coordinate, just different signs. The last one is 1/2, and then 3 over the square root of 2. So again, if I take that point, reflect it over the y-axis, I get this point, except it's negative, positive. So that one's going to be negative 1/2, positive square root of 3 over 2. If I reflect that over the x-axis, I get this point, which is negative 1/2, negative square root of 3 over 2, negative, negative. And then if I reflect that over the y-axis, I get this point, which is positive 1/2, negative square root of 3 over 2. So when I ask you random things like, okay guys, what is the tangent of 60 degrees? Well, the tangent of 60 degrees is simply y over x. So you take the y value of 60 degrees, which is the square root of 3 over 2, and you put it over its x coordinate, which is 1/2. But remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So I can just multiply by 2 over 1, and then continue on there and get the tangent of 60. Or I can ask you, okay, what is the cosecant of 210 degrees? Well, cosecant of 210, so cosecant is the reciprocal of sine. And if sine is opposite over hypotenuse, yes, but if sine is y over r, again, we're in the unit circle, so that means r is equal to 1. So essentially the sine is just the y value. And I ask you, what is the cosecant of 210? Well, cosecant is the reciprocal of sine, so that's going to be r over y. So I want to know, what is the essentially the y value for that 210 degree angle? Well, suppose we can't see the third quadrant, right? If you only generate the first quadrant on your test, hopefully you know you can find the reference angle for 210 by subtracting 210 minus 180, and you end up with 30 degrees. So you know that 30 degrees, you're going to use these coordinates for your reference angle for 210 degrees. So when I do r over y, I know that's going to be 1 over y is 1/2, and 1 divided by 1/2 is 2. So these are just some random examples out to the side, but the point being is that if you can generate the first quadrant, all of the other numbers are the exact same with different signs. So you should be able to figure out any of those by sketching out the bones, if you will, of this unit circle on your test. I hope this helps. If you have further questions, shoot me an email.